Working with JavaScript today. First starts out using our markup, and we can see on the markup where it's linking to a CSS file, it's linking to jQuery, and then it's linking to the JavaScript that goes into our project itself. It's now organized where we have a containing div to hold the whole project. Then we have a div that is now holding all of the non-canvas elements in a single div, so that can be positioned directly on top of the canvas element. So there's the canvas element, there's the non-canvas elements that we're referring to as game UI, and then that is broken into pre-game div, while the game is running div, so we could populate this with any number of things. Currently it just has a button, but we could have text up there, so it could be showing a score, we could be showing a timer, we could put other elements up there and then populate it during that state of the interactive. And then we have the when it's all said and done part of it, where we have the game complete. So we have beginning, middle, end, and that's all wrapped up inside the game UI div, and then everything including the canvas is wrapped up inside div as well. And we use the div so that we can then use our CSS knowledge to control the layout of these elements on screen. So got a bunch of markup here. I am going to kill the style sheet momentarily, so I'm just going to break all my links here so then nothing works. And now if we view this in the browser here, we'll see that it just purely is a bunch of text and a bunch of items happening. So I have my primary section with its text and its button, the reset which will show up, and the final part of it. Now if we bring back the style sheet here, but don't let jQuery work or any of our code, we'll see that we now have multiple items sitting on top of our canvas. The canvas being the dark color, and then we have this panel, or this stripe here, the stripe here, stripe here. So they're all putting themselves on top of it. Now remembering that this is game UI covers all of our non-canvas elements, so that wraps all of that in single item. Then we have game, which holds everything. So going into the CSS, standard zeroing, elements going on here. We're making sure the canvas gets treated as a block level element, throw a bunch of stuff in the body, some standard text things. We'll come back to our anchor tag, which controls our button class object, so we can get our cool things. But what we really care about now is looking here. So the game div that wraps everything, we can see it has a width associated with it of 800 pixels. And it gets a left-hand margin of minus 400 pixels because its left position is being set at 50%. So the canvas is being set at 50% and then being offset by a negative amount, effectively centering it. So this is an alternative to the margin auto technique, if you're familiar with that as a CSS thing. This is a different way that I came across and thought, wow, that's kind of fun. So let's roll with it. So this now creates the div that holds everything and centers it on our page. And it has been assigned a positioning statement, and that's useful because if you're specifying positioning information, you also need to specify the position property of an element. The canvas gets colored with the background. And now, and this is the cool part, is the game UI, remembering that game UI now we can see it. Game UI is all of the text and button stuff that shows up on screen, is a single div. So when we look at that div now, because its parent of game has position relative, then this gets absolutely positioned on top of that canvas element and on top of our game div itself, and then it gets its height and width. It's a good idea to provide sizing information for items when you are positioning them, because that makes the web browser happy, because then it knows how to do flow. It knows how to flow the page. If you don't provide positioning information or height and width information, specifically width, it gets really difficult for the browser to do any type of positioning, and sometimes it will get grumpy with you. And then the opening div, the closing div, they get some coloring on it, and then the middle div is getting just some text aligning information, but it's not getting additional coloring as part of it because it sits on screen while the game or the interactive is running. So that's the bulk of the CSS. A lot of this is just, so right now when we're looking at it, it's just standard CSS, putting elements on top of other elements. So you have to use your markup skills and your layout skills and create the page that you want. Now, the other thing that's happening here is what we're not having show up on screen is then, or hiding things yet, because the jQuery and JavaScript have been turned off, so we don't get to actually see where it hides certain things and only gives us a few elements at a time. So I've added a style rule in so that we can actually see borders occurring around the different divs. Anytime you're doing layout, I always find it's useful to throw just a crap border on all my divs just so I can see where the browser is putting them, and then use that as a guide. With the JavaScript here, jQuery is being loaded, and then our script is being loaded. It's occurring in the head of our document. Because we are loading it in the head, that means our JavaScript inside our project is going to have to load everything into memory before it has access to it, so we're going to have to take care of that. If we were to put it at the bottom of our document, so if we put the script down here before the closed body, then we wouldn't have to wrap everything in a document ready function. Effectively, what is happening is all of the JavaScript code from this line here all the way to the very bottom is just saying when the document is ready, run this function, which is the rest of the code, and that prevents it from trying to access elements that have not been loaded into memory yet. So document ready is jQuery's version of the window.onload method that we've used prior. The document ready from jQuery is considered a better performance element than the window.load or window onload item, because window onload has to actually load everything in its entirety, all of the picture, not just knowing, oh, there's going to be a picture here, so I'll just, kind of earmark that, but it has to load all of it. Document ready is able to get going before it has completed the loading of each and every element in its entirety, because it now makes a notation to itself and says, oh yeah, there will be an image here, and I'll keep loading that while I move on and go do something else. So it works well that way. So if we put this script at the bottom of our document instead of in the head, we could get rid of line 1 with the document ready and then get rid of the close of that down at line 102. You could get rid of those and everything would function just fine, because that would mean all of the markups loaded before we got to the script. So if you want to put your scripts at the bottom and not wrap everything inside, then you're welcome to do that. But if you want to have it up in the head so you have all of your scripts in that one nice tidy location, then you have to use the window onload or use document ready or something that prevents it from trying to access elements before they're loaded into memory. Another thing to be aware of with jQuery, so we're setting our canvas element where we say get our game canvas ID. So remembering that we're just using jQuery's get element by ID function. That's the $sign. If we have accessed the canvas object with jQuery, then when we issue our get context statement, we have to say that canvas variable dot get, and we have to then put parentheses 0 after it, because we have to use this dot get method versus just saying canvas dot get context 2D, which is how we would do it if we had done it without jQuery. Because when jQuery is accessing the element, then we don't, it's putting it into memory a little bit differently. So it's not the same as if we said var canvas equals get element by ID game canvas. If we'd said that, then we would just say var context equals canvas get context 2D. But because we did it through jQuery, jQuery is getting the canvas object. But we also then, when we want to get the context, we have to say get the first node of the context. Because if we think in terms of within my document here, I have my HTML node. And then attached to that, I have a head node and a body node. Attached to the head node, now there's a title node and a meta node and a link node and 2 script nodes. Attached to this body, now I have this div node, and then inside that is another node. Inside that is another node. Inside that is another node. So when in jQuery, when I start saying get element game, I could actually refer to any of the elements contained within game by their node position. The node is simply an array containing all of those objects. So when we access the canvas through jQuery, we have to get its context by saying canvas.get and then specify the first node, the object in position 0 in that array. For that reason, I'm just as happy to say var canvas equals document.getElement by ID game canvas. And then I could say var context equals canvas.getContext2D. I almost like that better, but because we're trying to gain some experience using jQuery, we have to know that this getting the canvas is a little different of an operation when we're using jQuery versus not. So you can go do some research online and just look up getting the context of the canvas using jQuery, and you'll find it will give you an even more in-depth and technical explanation of using the get0 method that's been attached to it. Now we also are setting 2 variables here, our canvas dimensions, and we're saying canvas width. Now if we access the canvas using not with jQuery, this variable could just say var canvas width equals canvas.width, and it would be done. But because we accessed it through jQuery, we now need to access the width and height of the canvas using width as a method or a function, so it has the parentheses after it. So this is part of, if we do certain things with jQuery, it requires us to do some of these subtle details or nuances afterward with jQuery. And when you go back and forth using it, not using it, using it, not using it, it's really easy to forget some of those things, and you can't figure out why you're getting weird error messages. So I'm pointing these out. I personally prefer to get my canvas not using jQuery, so then I don't have to have the .get. I don't need to use methods of it here. I can just say .width, .height, and be done with it. That's my preferred way, but you can do it as you will. Now, an explanation of why we're accessing the width and height and setting variables to that. The reason that we will do that is because when you are doing any type of animation or interactive programming, you often need to know what are the perimeters, the top, bottom, left, and right of that canvas. So when an object moves off screen, you need to deal with that. Whether you wrap it to the other side or that affects a score or something like that. So we need to know what the width and height of the canvas are so we have those numbers available to us. It's also important because we don't want to be asking every time what is the width and height. This way we ask one time at the beginning and set a variable equal to that, so we don't have to keep making that query. We just now know that number and that number's in memory. It also is possible to set the width and height of the canvas directly in the JavaScript. So we could be setting it equal to these values, and as part of it we would know them in the script and wouldn't have to make that query. That's another way we could do it, which would be different than hard coding it in. And even though we hard coded the width and height of the canvas here, we can always override that in the JavaScript. So we could even take the canvas and change its width and height at some future point while our program is running. So the width and height of the canvas is not a fixed value that once the page loads we're permanently stuck with. We can adjust it based on what is happening in our interactive. So we now jQuery method, non-jQuery method, just comment that out, but they're equivalent. So you can work with that. So we grab all of our divs and elements and our buttons and everything. So everything with an ID, we're grabbing that and throwing it into a variable so we have access to that. That's the game UI. Now, to look through the functions and see what's going on here, there's only going to be a couple new lines of code that we have not used before, because we've looked at using key code a little bit, but we do have the jQuery method of window key down and window key up that I'll get to. So that's the second thing that we haven't done. And then the third thing that we haven't done before is we're using unbind. And I'll explain what that does in a little bit. But otherwise, there's not actually really anything going on here that we haven't played with before, which is kind of cool. Because we used hide and show with jQuery before, so we've done that. And then the basic logic of putting things into functions. So using our function expressions here and working with that. We've done a little bit of work with set timeout before. So now it becomes a matter of let's figure out the order of how things are happening in here and look at that order. But as I said, there's really only three new things here. How we're getting the context, and then using the key down and key up function, and then using unbind. Those are the only new things. So as I promised, there's only a couple new things today, which is unusual for me. So there you go. Now looking through this, so we grab everything, throw it into memory so we have a memory reference to that. You can compare that to the markup and do the back and forth and understand what's happening there. Now, we have start game, not using that right away. Init, not using that right away. Animate, not using that right away. So there's our three functions that are being built into the project. So at the end of everything, after we've loaded all of our items into memory, we've put all of our functions into memory, we finally get down to line 107, which calls init. So to look at the order that we go through it, so init runs. So let's go find what init does. Okay, here's init. So init tells my stats and UI complete divs to hide themselves. So remembering that everything by default is set to a display property of show, and when we use jQuery and say .hide, it sets the display to none, effectively removing that element from the document flow. And when we say show, it puts it back in the document flow. It's display block, display none, display block, display none. That's what hide and show are doing. So we hide 2 elements of our markup. So we have game intro, then we have our game stats and game complete. Those 2 divs, which are, if we look up here, we have our stats and complete. So those 2 divs are now being hidden when a init first runs. Then it's setting up and saying the play button, it's assigning a function to it so that when we click it, then it's going to hide the intro section and call the start game function. Then if we continue down, we'll notice that the other 2 buttons in our project also have their functions attached to them. So what we're doing under init is attaching the functionality to all of the buttons for the project right away at the beginning. Even though we won't see those buttons right away, we only get to see the play button, it attaches that functionality so it's now in memory ready to go for when the buttons do eventually show up. So the first button, play. And I'm going to just ignore the prevent default for now. We'll get to that a little bit later. And now we tell the intro to hide, and then it calls the start game function. So then we can scroll up and see what is start game. Well, start game now tells our middle div stats to show itself. It initially will make play game false because we don't want the game to start running right away, because as soon as you click the button, it's nice to give the player a chance to take everything in before anything happens. And if you remember the instructions, it also is tied to pressing a key. So when I press a key, then it actually starts the game running. So it sets play game equal to false. So if we ignore the keyboard stuff, we can see, okay, so if the keyboard stuff is not there, all the stuff highlighted, pretend you can't see it. Put on your blinders. So it makes stats show, sets play game equal to false, and then it calls the animate function. Okay. So we can go down and find out what the animate function is and take a look at that. So animate says, if play game is true, do all this stuff. Well, going back up to start game, we'll see that it starts out and says, play game is false. So when I run this in my browser, when I run this in the browser, I hit play, and now we can see the game is not running right now because play game is currently set to false. If I want, and I pressed a key, which makes play game become true. And oh, by the way, if you're running this on a laptop and you're not plugged into a power source and you just leave this tab up and go back and forth, you can watch your battery drop because this will eat up all of it. So a good idea sometimes is just give yourself an empty tab and click over to that before you head back over to your code editor and start working. Otherwise, because it's up in the browser, it will just fry. I went from 3 hours down to 20 minutes in the span of half an hour on my battery. And all I was doing is working on this sample because I forgot to get that out of the non-active tab. Once I got it out of the non-active tab, I got back up to about 40 minutes, but my battery was now very hot and unhappy. So just keep that in mind. So play game starts as false. And if we look under animate, because if we remember, so if all of this code here, I'm even just going to get it out of there, we make our middle div stats show up, we set play game equal to false, and then we call the animate function. That's what start game does. Now, animate, when we look at that, it says if play game is true, and I could write this out as true, like that. So if play game is true, then it starts doing where it clears the canvas, draws a rectangle, and then it calls the set timeout method. Set timeout just simply says, all right, I'm starting my stopwatch, and after this much time has elapsed, I'm calling this function. Well, if you notice, it's calling itself. So this is a common way to build an animation or interactive loop, because there is no just on enter frame like Flash has, or in processing where we just have the draw loop. Here, there is no pre-built kind of sequential timed frame-based loop. So to create this looping sense of time, we use set timeout. You can also use set interval, but set timeout seems to be winning as the favored method at the moment, unless you use the more advanced method, which requires you to bring in a little snippet of code from someone else, and it's called request animation frame. But we're not going to go into that this morning. We'll just use set timeout because it's really simple and clean to work with. Set timeout fires. When its time is up, it calls whatever function has been listed here. In this case, it calls animate. So it keeps running, and it keeps running until play game reaches the state of no longer being true. Because if it calls animate, but play game is false, then it won't run anymore. So that's the little kind of magic trick that's going on here, and the code logic that's, I think, just a really clever solution for making this happen. Because we can see when I click the stop button, it sets play game equal to false. So when I hit the play button, it calls start game. Start game makes the stats div show up with the stop button, sets play game equal to false, and it calls animate. It also registers this keyboard stuff. And then animate, well, as long as play game is false, nothing happens. To make play game become true, the only way to do it so far in the project is to press a key. To press a key down. And when we press a key down, play game, if it's false, becomes true. And then at that point you can recall the function animate, and you can call it from 10 different places, but only one copy will run, so it doesn't. By setting it true, we would hope that it's already running, but if not, we guarantee it's running by recalling the animation loop at that point, even though we did call it previously. When I press a key down has start game registers the key down and key up event listeners. So if we weren't using jQuery, we would have to be using window.addEventListener and then tying it to the key downs and key up functionality, so on key down, on key up. But by using jQuery, it really does, this is one of those areas where it works really stinking well to use jQuery for it. We can just say, hey, grab the window, and for the key down event, run this function. That's what happens here. So key down, it takes and puts this event, it grabs it using our shorthand notation of E referencing that event, and it creates a variable key code and sets key code equal to this particular event. So when I press a key down, that key being pressed down has a key code property. So the event itself has a property of which key was pressed. The computer knows and assigns a number to that. Left arrow is 37, up arrow is 38, right arrow is 39, down arrow is 40, space bar is 32, shift is 16, and those are the only ones I know offhand because those are the only ones I ever regularly program for. So we know that we can get certain key codes and we could do something with that. Currently, this program isn't doing anything with it. It works with any key. But we could take this logic here and we could wrap it in an if statement that says if key code, the key code of this event is equal to a specific number, then do this stuff. So we could do that. And we could be grabbing it that way. We're just not yet. We might in coming sessions. So when I press a key, if play game is false, it sets it to true and recalls the animate function. Going back to animate, if play game is true, then it clears the background, sets the fill style to kind of this grayish pink, and then it draws a rectangle at a random location. Then it calls set timeout, which will then loop through and call the animate function again until some other event makes play game false. And it does it 1,000 divided by 60. So 1,000 milliseconds divided by 60 gives me approximately 60 frames per second, which is a very common frame rate for interactive in-game programming. That's considered the ideal target frame rate is 60. That gives you the smoothest animations on screen. It typically also corresponds to the hertz of monitors, which at their worst settings are usually set at 60. So then if it's at 60, we're redrawing our frame loop every 60 times per second. That gives us a very clean image on screen. Now, when I click my button, so we have key down and also then key up. Currently we're not doing anything under key up yet, but again, as we build more complex examples, so if we're using keyboards to move things around on screen or do stuff like that, we could worry about based on key codes. So when I press something, it sets a Boolean to true. When I release it, it sets it to false, using that same kind of keyboard Boolean methods that we've used in Flash, we've used in processing, we've used in these other languages. So we could place that logic in here, because once we access something, window key up function, so that's saying, hey, listen for key up. This says listen for key down. The logic inside the function that we're doing, it's actually the same in every language. The logic is and what we need to do. So we say, hey, if it was this key code, do this. If it's that key code, do that. So we can track all of that. It makes it pretty easy. Now, going back to the buttons also have a reference to their event, and the reference is E, prevent, default. So this is now making sure that whatever else is happening with the button, it's only doing what we want, and it's typically a good practice that when you're making something clickable, that there's event bubbling, and it's a more complex topic than we want to get into this morning. But the easiest way is you just leave that line in there, and most of the time then when you write the code to make things clickable, it behaves a little bit nicer and cleaner. If you take that out, 95% of the time everything will work just fine, and you'll never know that you needed it. But that few percent when things behave erratically, that's when you're like, oh, why is this not working? And it usually comes down to the default behavior for a button or something that's clickable. So we just prevent that default behavior from happening and make the behavior we want to have happen occur instead. Now, our stop button needs to do one more thing, and that needs to unbind key down and key up. Because otherwise what will happen, because under our start game, it now attached to the window key down and key up. And those stay attached to the window no matter what else is going on in our program until we say otherwise. So when I click the stop button, I need to set play game equal to false. If I don't do that, well, we're going to be playing for a while. So I'm going to even just comment this out, and we'll save and watch what happens. So I click. It's waiting for a key. Now it starts going. Now I hit reset, and we can see if I don't set play game to false, it's not going. Now when I go back to the beginning, yeah, it's still going, still. And now it's waiting for a key, because the only time that it gets set to false, is when start game is called, where it starts the game and it sets it to false and waits for a key to be pressed to make it true again. So we kind of need this. This is the event that needs to, when we click the stop button, we say we're no longer playing the game. We could also, instead of having it tied to a stop button, we could have it tied to If you have a timer going in your game, so we've run out of time. If you have movement going on, so you've moved something off screen, that ends it. So depending on what event you want to have stop your repeating loop, you need to then put your play game false in that event. Now, if we go back to it again, play, that's waiting. So I stopped it. Oh, sure, now it's behaving. All right. Oh. Now we want. All right, it's behaving. It didn't behave. It behaved correctly for me last night. But the unbind that we have here, what unbind does is it says stop listening for those keyboard commands. So when we don't want to be receiving keyboard information and having anything happen, we use unbind to remove it. Effectively, what has happened when we say window.keydown and then this function is we are binding the key down event to the window. And there is a different way that we can actually write. There's a bind command. And if this code were contained in its own function instead of just being referenced directly here, there's a bind command that we could issue where we could say window.bind on the key down event this function. So it's possible that we could actually put that in. So we could explicitly say we used bind. And then we are explicitly saying unbind. So we can do that. But it's a good practice anytime your project is done and is no longer going to be needing keyboard input to use unbind to say stop listening for keyboard commands. Also notice that keyboard events are attached to the window. They're not attached to the canvas or to a div or to anything else. Because we attach different commands or different listeners. So the click is attached to a button object or to a div or to whatever else we're attaching it to. But keyboard commands are a window event. So we have to remember that they're always attached to the window. Now, if you want to turn this into then something more interesting than a little box looking all spastic on screen, we can see inside your animate loop where it says the actual gamer experience stuff, that's where you put the bulk of your code. That's where you will put all kinds of cool interaction. You'll be drawing, spaceships or aliens or pretty flowers or whatever you're going to include as part of it. That's where that repeating content gets put, is inside the animate function. And heck, you don't even have to use clear. You could even use where you use the translucent fill style and draw a rectangle that covers the whole thing, so you get that kind of slowly fading out background. All kinds of neat things. I mean, there's no limit. It's just based on your creativity as you choose to solve it. So when it's all said and done, we look for the flow of the document here. So it says after everything is ready to be accessed, do something. So it grabs my canvas, puts that into memory, grabs the width and height of the canvas, puts that into memory, grabs all my divs or my button objects, puts those into memory. Okay, there's a function that isn't called yet. There's another function that's not called yet. There's another function that's not called. Ooh, look down here. Okay, now that calls a knit. So now we go up, we find a knit. A knit goes here, so now it hides my middle div, hides my ending div, and then it attaches information to each one of my button objects. So it gets those buttons ready to go. And now my document is waiting for me to do something. It's waiting for me to click. The only thing I can see is my play button. So if I click on my play button, it now hides the first div, the intro div, and then it calls my start game function. So then I move up and go find start game. So we go through the document in the order that it's called, line by line, figuring out what gets called next, because invariably when you work on a project, you will run into issues where things are happening out of sequence. And if you look through and go, okay, what's called next? What's called next? What's called next? That really does help you to see how the document is put together, but also then how it ends up working on screen. So the start game shows my middle div of my stats, sets play game equal to false. Okay, and now it registers the keyboard stuff, calls animate. Well, play game is false, so animate's not going to do diddly squat yet, because that's waiting for me to, oh wait, press a key. So when I press a key down, it sets play game to true, calls animate again to make sure it's paying attention and is awake. Animate says, oh, play game's true. Awesome, I love you. Now I'll clear the background, and then I'll go draw this rectangle in some weird random position, set timeout to go 60 frames per second, that it will recall animate, and as long as it keeps staying true, it keeps drawing itself. And then we can see that the div on top, stop, is going to be visible, and when I click on that stop button, it will set play game to false, stop listening for keyboard commands. It will hide my middle div, my stats, and then it will show my game over or my complete div and put that on screen. Well, my game over complete div then has a function on its button, the play again button, that will hide the game over div, shows the starting div, clears the background. And well, if I can see the starting div, that means it's waiting for me to press the play button, which we'll call play game. I've got a loop. I've got a loop, and it just keeps going. It just keeps going. But follow it line by line by line. That's how you start to figure out how these things fit together, work together, and become a finished project.